when we are dealing with equilibrium problem, there are always a lot of ions involved in the system. And if we're trying to calculate the concentration of each ions, we need to set up a lot of equation, right? Because we have a lot of variables. So if you need to solve the numbers for each variables, you need to set up the system of the equations. Depending on how many variables you have, you will have to set up how many equations to be able to get the solution, right? And to do that, we can utilize the charge balance and the mass balance in the solution. First of all, what is charge balance? It is also called electron neutrality, or you can say that it means that the sum of the positive charges in solution equals the sum of the negative charges in solution. So simply saying that when you consider all the available ion in the solution, the number of positive charges should equal the number of negative charges, because overall the solution should reach electron neutrality. Okay, that's the charge balance. And the mass balance is also, you can also say it's a way of describing the conservation of metal. So simply saying how much you add to the solution, you should always have the same amount in the solution. Why are we saying that is when you add something into the solution, it might be going through some chemical reaction or physical process, change to different ions or complex ions, but it doesn't matter how many forms you have. The total amount of that specific atom or a group of atom should, if you add them all together, it should equal the amount of that atom or group delivered to the solution. Okay, so we will talk about them in details by using examples. First of all, charge balance. Okay, charge balance again is the sum of the positive charges in the solution should equal the sum of the negative charge in the solution. Now let's deal with a simple example here. If we have a calcium chloride solution, okay. First of all, I want you to think about what are the ions present in the solution.
Ca and Cl.
Yeah, we have Ca. Pay attention to the charge, okay? We have Cl. And what else?
H plus and OH minus.
H plus, OH minus, okay? So that's what we have. Now, let's put the positive charges on one side and negative charge on the other side. So we have calcium, okay? We have hydronium ion. So both of them are cations. And then on the left side, on the right side, we have chloride and OH minus. Okay. So is this correct? No? Okay, so what was the problem here?
You have 3 positives and 2 negatives.
We're not simply adding them up because they're not like, the calcium is not simply distributing 2 positive charges. You need to consider the molarity, right? You might have more calcium than hydronium ion. So it's not a simple 2 plus 1. Okay? Overall, you need to think about the total amount of positive charges and the total amount of negative charges. But still, there's some problem with this equation. So we're trying to calculate the sum of all the positive charges and the sum of all the negative charges. But we're using here is the molarity, right? Those are molarity. And think about 1 mole of calcium. how many moles of charges it's contributing?
2.
2.
2, right? So you're actually contributing 2 charges, which is why you need to multiply this by 2, right? So by doing this, you're considering all the positive charges contributed by the cations. And for the rest of them, because they're only carrying 1, so you don't have to multiply any coefficient. Okay, does that make sense? Because you're actually not counting the ions, you're counting the charges carried by the ions. And because calcium is carrying 2 ions, so you need to multiply it by 2. Okay. I think someone said it doesn't make sense. Can you let me know which part is? So does that make sense when I say that when you're counting the total charges, you're not counting the actual number of the ions. You're calculating the charges on the ions. And because one calcium carries 2 positive charges. So if you want to calculate the amount of charges carried by the calcium, you need to multiply the amount of calcium ion by 2. Again, because 1 mole of calcium actually contributes 2 mole of positive charges, right? Now, if you have aluminum, then you will use 3 multiplied by aluminum concentration, because every 1 mole of aluminum will contribute 3 mole of positive charge, right? Same thing with sulfate anion. You will have to multiply by 2, because every 1 mole of sulfate will contribute 2 mole of negative charge. Okay. All right.